Welcome once again to the continuation of subject of formulae. In our previous lesson, I gave several examples under the topic subject of formulae. I understand the importance, how useful this topic is in science. Now, here is the B part. We are given in this question a to the power of 2 over 3 multiplied by r divided by s. Then the other side here we have the cube root of a squared minus l squared divided by t. The question says we should make letter A subject of the formulae. In this question now, our A appear in two different places, which means we have to bring A together. Aside from that, there is a cube root which we need to remove. So unlike the previous example, we have L attached to A by sign, negative sign. So before you can do anything here, you have to first remove the cube root. So that was the first thing we can do before you can relate this part of this question to the other part. So let's go together. Let's solve this together. We want to make A subject. So we are given A to the power of 2 over 3 r divided by s equals cube root of a square minus l square, everything divided by t. Now, the first thing to do in this kind of question, since what you want to make subject is inside the root, sometimes what you want to make subject may be inside the bracket. So for you to link what you have in the bracket with what you have outside, you have to first open that bracket. Here now, because of this root, we can access A. For us to access this A square now, we have to first remove the root. So now here is cube root. So now you have to find you raise the power of each side of this formula or equation to 3. So that because this cube root means raised power of 1 over 3. For us to remove this power, we have to multiply by 3. So that's why you have to take each side to power of 3. So now let's take each side a to power of 2 divided by 3 r divided by s, raise it to power of 3 because we want to remove this cube root, equals cube root of a square minus l square divided by t, everything to power of 3. Now, this 3 will remove this cube root because this cube root is same thing as a square minus l square over t raised power of 1 over 3. So by the time we multiply this 3 by this power, this root will disappear. And also, whenever you have a power, you have several variables inside the bracket. So the power belongs to each of these variables. So because of that, we are going to raise this a to the power of 3, r, s, everything to the power of 2. So now we have a raised to the power of 2 over 3 before. So now raise it to the power of 3. R also to the power of 3. S also to the power of 3. Everything equals, so this is gone now, so we have a square minus l square, everything over t. Now from here, the power here will affect the power here. So you have 2 over 3 multiplied by 3. So 3 is gone. So that is just a raised to the power of 2. So now I have a raised to the power of 2, r to the power of 3, s to the power of 3 equals to a raised to the power of 2 minus l square divided by t. Now, we can remove the denominator. So we can cross multiply What that simply means, if I don't want to use cross multiply, what you have as denominator here and here, that will be your LCM, because there is nothing common. So your LCM will just be s to the power of 3t. That will be the LCM. So now you multiply both sides by this LCM. By the time you do that, it's just like you cross multiply, because by the time you multiply this side by s to the power of 3t, this also by s to the power of 3t, you can see that this t is gone. This is also what? Gone. What is left now? It's just like you cross multiply. So that's why some people will say you cross multiply. But ordinarily, we are multiplying each side by the LCM. Now we have a to the power of 2 r to the power of 3t equals a to the power of 2 minus L square, then s to the power of 3. So this is what we have after the cross multiplication and division. So this is what you have. So what we did here, we multiply both sides by the LCM. So you know your LCM is s to the power of 3t. So this s to the power of 3 will cancel out, so you have t. So you multiply t by this, you have this. T will cancel out t here, so you have s multiplied by this, and you have this. So you don't just write times, because if you write multiplication sign only, s will only affect L, it won't affect A. And also, if you write like this, you have something like this, this is wrong. Even if at the end you get it right, but this expression is wrong, you cannot write this. So because of that, we use bracket. Now what we need to do, you open the bracket and collect the like terms. So we have a to the power of 2 r to the power of 3 t equals a to the power of 2 a to the power of 2 r to the power of 3 t equals a to the power of 2 multiplied by s to the power of 3, that's s to the power of 3, minus, multiply this again, open this bracket with this, s multiplied by this, you have this, s raised to the power of 3 multiplied by this, you have L square s to the power of 3. Now we can collect the like terms. So let's collect the like terms. So you bring this to this side. So you have a to the power of 2 r to the power of 3 t minus, by the time you bring this, or you subtract this from both sides. By the time you subtract this from both sides, this will be 0. So you subtract from this side, you have a 2 s to the power of 3 equals negative L square s to the power of 3. Now, I want to continue here. You can see now that a to the power of 2 is common. Yeah. So I can just take out my a to the power of 2. Then I have r raised to the power of what? 3 t minus, take a to the power of 2 here, you have a minus s to the power of 3. Close the bracket. Everything equals negative L s to the power of 3. Now, we can divide both sides by this one, since this is attached to this. So now you have, by the time you divide this both sides by this, you have your a square equals negative L s to the power of 3 divided by r is power 3 t minus s to the power of 3. And since the question says make a subject, what we just need to do, you take the square root of both sides. By the time you do that, you have a equals square root of negative L s to the power of 3 divided by r to the power of 3 t minus s to the power of 3. And this is the solution. Here's the final result. So we're able to make a what? A subject of the formulae. Now let's consider the second one. Here we are given this. We have S equals N r to the power of 2a minus 1 divided by r minus 1. The question says make a subject. Now I want to make this a, which is the power. This time, this is entirely different from all the examples we've done so far. So now let's see how we solve this. Don't forget the rules. We want to ensure that we move away all the parameters, all the letters, all the variables that are attached to a, so that we have a in one side, others in one side. Now let's move together. Now let's try to remove all this. The denominator here, we have something divided, so let's cross multiply first. So now you have a s r minus 1. You cross multiply, so this will come, this is s over 1. R minus 1 will multiply this will multiply this. So now this equals to n r raised to the power of 2a minus 1. Also, this n will not make it easy for us to have access to a. So because of that, we divide both side by n. So now you have when you divide both side by n will go here, so you have this over n. So now you have s r minus 1 over n equals r raised to the power of 2a minus 1. This is what we have. Now again, we are trying to remove all those letters that are attached to a. Here we can remove this one and by adding 1 to both sides. So now you have a s open bracket r minus 1 divided by n. By the time you move 1, so plus 1 equals what? R is power of 2a. Again, we are getting there. We are getting there. Now the next thing to do, want to make the power subject. What should we do? You take the logarithms of both sides. You take the logarithms of both sides. For convenience, you may first decide to take LCM here so that you have your s r minus 1 plus n divided by n equals to r to a. Hope you understand this. LCM here, this is 1 over 1. By the time LCM here is n. So x open bracket r minus 1 plus n divided by n equals to r to the power of 2a. Now when you have something like this, how do we make a subject? So anytime the letter or the variable you want to make the subject is a power, what should come to your mind is you take the logarithms of both sides. Now let's take the logarithms of both sides. We have log s r minus 1 plus n divided by n equals to logarithms of r to the power of 2a. Now from here, we can divide both sides. No, you drop the power. When you have logarithms of a number to power, you can drop that power so that you have a log s open bracket r minus 1 plus n divided by n equals to 2a log r. Log r. Now, you can divide both sides by log r so that you have 2a equals whatever you have here. So now let's divide both sides by log r. By the time you divide both sides by log r, you are going to have a log s open bracket r minus 1 plus n divided by n, close the bracket, divided by log r equals to 2a. And from the rule of logarithms, look at this. The base here and the base here are the same. The base is automatically to base 10. Or I may decide to be to base e. So what I just want to take from this is the base here and the base here are the same. So I can just rewrite this. I can combine these two logarithms together so that I have log s open bracket r minus 1 plus n divided by n to base r. I can combine these two to form, instead of log, this is log r. So when you combine the two together, you have, since you are dividing logarithms of a number to the same base with each other, so you can just combine them together to have this to base r. Now equals to what? To a. Now make a subject from here. What do we do? This is very simple. You divide both sides by 2. So when you divide both sides by 2, so your result will be 1 over 2 log s r minus 1 plus n to base n, then no, divide by n, then to base r equals to a. And if you want to rewrite this, I can rewrite my final result as, in logarithms, the coefficient of your log can still be written, we can turn it to power. So this will now be log s open bracket r minus 1 plus n divided by n, everything raised to the power of half to base r equals to a. And this is the end. So meaning when you make a subject a, this is what you are going to have. Somehow this look interesting. A little bit. We can just say this is just intermediate. It's intermediate. It's not beginner level again. So, but just apply the rule, follow the steps, and you get it right. Now let's consider the last one. So to the viewers, one thing about math is practice. You have to continue practice. You start from the given example. You try to you attempt that example on your own. Try to solve. Will you get the same result as you have it in the example? Then from then you attempt questions similar. Then you try to take questions that are a bit different. And that is how we move on. Now let's consider the last one. Let's consider the last one. The last example here, we have we have r a square minus ka equals to n. Look at this question. Unlike all the examples we've solved so far, we have a square, we have a. Ordinarily, if both are a square, this is just like a question we solved earlier. But now the question is not the same. A square, a. This is just a quadratic equation. So we are going to use completing the square method. We cannot use ordinary factorization because you don't know the value of r and k, so that you can think of a product and the sum. And the only way you can solve this is only using a completing the square method. With completing the square method, we can easily make a subject. Alternative way is to use your general formula, which some call almighty. I don't know how it is almighty. It can only solve few quadratic, not all quadratic equation it can solve. So because of that, don't call it almighty again. So we call general formula. It says that under a reasonable condition, if you have just only a square and a, or x square and x, you can still make use of it. So now let's go. We want to use completing the square method. So the first thing that should come to your mind when you are working with completing the square is to ensure that coefficient of a square is 1. That is, the highest degree of x or the highest degree of a is 1. How do you make this 1? You divide through by r. Immediately you divide through by r. If this expression now you can factorize, but here you can still divide to remove. So now let's divide through by r. So we have a r a square minus k a equals to m over r r. So you know this we go. So now we have a square minus k over r a equals to m over r. Now we have this. I want to make a square, so a subject. Now you complete the square of this. You do what? You complete the square. How do we complete the square of this one? It's very simple, please. Watch my video on the factorization of using the completing the square method. It's there. So, but I will still explain. Though for details, you can watch the video. Now look at this. You have a square minus k over r a equals to m over r. What you just need to do, you take a. Now the coefficient of a here is what? K over r. Divide it by 2. By the time you divide k over r by 2, you get k over 2r. Now that k over 2r, you know the sign here is negative. You are still going to use the negative sign. If the sign is positive, you use positive sign. Because this sign is negative now, so we are using negative sign together with what we have here when we divided this by 2. So now minus k over 2r. Now square your result. Square this one again. You have what? K over 2r, everything square, right? Now take it from this result. Minus k over 2r, everything square, equals to m over r. And that is how I said earlier, you can watch my video on the completing the square method. Now from here, you can now see that we have a separate, other letter separate. What we only need to do is to make sure that we only, as we have a here now, we make sure that others are moved to one side. And let's start from here. This one is taken, is subtracted, so you move it to the other side so that it becomes a plus. So now you have a minus k over 2r, everything square, equals to m over r minus, okay, now minus this to the other side will be plus. So plus k over 2r, everything what? Square. Again, we can see now here that we cannot remove this one from a without first taking this. So we have to first remove this power now. You know, this power is not directly joined to a. Joined to a with other variables. So you have to first remove this power so that we can take this away. Now this is square. To remove square, you have to take the square root. If this power is 3, keep root. And that is how you continue. If it is nth root, 5th root, 3rd root, and just that way. So now we take the square root of both sides. So now we have a minus k over 2r equals, by the time you take the square root of this, you also take the square root. By the time you are taking the square root, this will be positive and negative. Why is it positive and negative? Because, when you say square root of 4, some people will say the answer is 2. The answer is wrong. It's not only 2 that we give you, that when you multiply, we give you 4. It will be plus or minus 2. Because either 2 times 2 or negative 2 times 2 will give you 4. So that's why you have to use the positive and negative sign. So that is why you have to use positive and negative sign. So now here we have plus or minus square root of m over r plus k over 2r, everything square. Now, our problem is almost solved. You can just, since we want to make a subject, move this negative, this to the other side, so that, immediately you move this to the other side, you have it positive, right? So now you have a equals k over 2r, which is now positive, plus or minus square root of m over r plus k over 2r. And this, we can now see that we are able to make a subject here also. A equals to this. So try as many as possible questions. So practice, practice, practice. So we stop here for now.